Hello, Algebra 2, and welcome to Lesson 7.4, where we're going to expand our knowledge with logarithms. So some background knowledge that we're going to need to know is how some exponent rules work. So if we look at our multiplying two powers at the same base, so if we have a 5 to the first power times 5 to the third power, we can rewrite that as 5 to the 1 plus 3, which ends up being 5 to the fourth. So we can simplify any powers at the same base if we're multiplying them by adding their exponents. Now, if we look at a couple of logarithms and what happens when we add those. So here we have a log 5 of 5. So that would mean 5 to some power needs to equal 5, plus a log base 5, 125. This would mean 5 to some power needs to equal 125. So those logs, remember, are solving for exponents. So our first log has a solution of 1 because 5 to the first power equals 5. Our second log has a solution of 3. 5 to the third power equals 125. And then 1 plus 3 is 4. So it's important to know that when we're dealing with logarithms, we're really talking about the exponent in a power. So the log 5 of 5 is 1. The log 5, 125 is 3. We're adding those together to equal 4. Now you could also look at when you take 5 times 125, that's going to equal log base 5 of 625, which also is equivalent to 4 because 5 to the fourth power is equal to 625. And that leads us into our first rule with logarithms is if you have a log base b and equal to some product, you can do what's called expanding that log. You can rewrite it as log base b of m plus log base b of n. Because this product right here is like the multiplying of two powers, we can rewrite it as the addition of both of those exponents. And that leads us into the quotient property. The quotient property says that if you have a log base b of two numbers being divided, you can rewrite that as log base b of m minus log base b of n. That's because when we're dealing with powers, if you divide two powers, like if I have 5 to the third divided by 5 to the first, I can rewrite that as 5 to the 3 minus 1. So those logs, remember, are exponents. So we're just talking about the exponent process that happens when you divide two powers. And then lastly, a power property. Whenever we have a log base b of m to some power, we can rewrite that as a coefficient out in front, n times the log base b of m. So that comes from the power to a power rule. So like if you had an x to the second, and then you raise that to the fourth, you're going to multiply those two powers. That would be x then to the eighth. So that last one is dealing with the power to a power exponent property. But as a log, anytime you have an exponent as part of your log, you can rewrite that exponent as a multiplier out in front. So today we're going to practice two things. We'll practice doing what's called expanding logarithms, and then we'll also practice what's called um, condensing logarithms. So we'll start with the condensing. So we'll show our work for part A up here and then part B below. So I have two logarithms, and we're going to find out what is each logarithm expression written as a single logarithm, and then if possible simplify that single logarithm. So anytime we have numbers and we can possibly get the logarithm simplified to a single answer, a single exponent, we'll do that. So looking at part A, I got log 3x minus 2 log 3, 7. So I'm going to start the process of condensing this log down to 1. Now, since they both have a base of 3, I can start to use my properties from above. So first is this 2 out in front. I can take that 2 and I can write it as the exponent of 7. So that's going to be log 3x minus log 3, 7 squared. Now 7 squared, since those are both numbers, I can think of that as 49 as well. But now I have a subtraction between my two logs. So I have a log base 3, and then I have a subtraction. That means that my two numbers in my log are going to be in a quotient or a division. So I'd have an x divided by 49. And now I got it down to one single log. So the subtracting of the two logs is going to give me the two numbers, x and 49, those are going to be involved in a division. Heading to part 2, I've got a log 8 48 plus log 8 4/3. So since this is a logs that have both base 8 and it's a plus, I'm going to multiply those two. So this would be log 8, and then I'll take 48 times 4/3, which is going to be 64. Now when I have numbers, I'm going to check to see, can I simplify this log? So this one would be asking for 8 to some value needs to equal 64. So that simplifies. I could use my power sheet. That's going to equal to 2. So that would be my final simplified log. So if possible, as you're condensing, you get down to the end, you have all numbers, you can check that power sheet, see if you can simplify your log. The other skill that we're going to practice is looking at expanding your logs. So we've got log 5, 125 over xy. So first, we can see that we have this quotient. So we have the 125 in the numerator and then this product xy in the denominator. So I'll start by using my first log rule, which with a quotient, I can subtract the two numbers that are in the numerator denominator. So log 5, 125 minus log 5 xy. So there would be my first step, starting to expand this out. Next, I have this minus log 5 xy. So this xy is the product that was all in my denominator. So I'm subtracting this log 5 xy. Now from above, when we have a product, we can rewrite that as two logs being added. So I'm going to have a log 5 25, which as I look at that, log 5 25, that is going to be 5 to some power equals 125. So that's going to be 3. So we'll just rewrite that as 3. And then we're going to have a log 5x plus log 5y. So since x and y are both grouped together in the denominator, I'm going to put them into parentheses. Now, since I have this minus out front, I'll distribute that out. So I'll have 3 minus the log 5x and minus log 5y. So there would be our final expanded log. So I can take that numerator, that becomes 3, and then since both x and y are in my denominator, I'm subtracting both of those. Heading then to part B, I'll kind of start over here to get some room. So part B, I've got a log x squared, y squared, and then z to the negative 1. So I'm seeing I've got 3 separate numbers being multiplied. So I'm going to start by expanding my log to show those 3 are being multiplied. So I'm going to use that very first property, the logs. When the numbers are being multiplied in your log, you're going to rewrite that as addition. After that, we each have a power on each of these that we can rewrite in the front of our log. So we'll take each of those and rewrite them in front. So eventually, we'll have a 2 log x plus 2 log y. And then since that negative 1 comes out in front, we'll go negative log z. Or you could put negative 1 log z, but that 1 isn't going to do anything when you're multiplying it out. But there would be our final expanded log. We'd have 2 log x plus 2 log y minus log z. So there is our expanded log. So if we're expanding, we're trying to use those properties to write multiple logs to get our practice with these log properties. So the next thing we'll look at is something that's going to be helpful as we get to section 7.5 as we start to solve exponential and log equations. It's the change of base formula. So change of base formula allows you to find the value of any log using a common log, or actually you can choose any base that you want to to find it, but the change of base formula I have written there is using common logs. But it says that if you have a log base b of m, you can find it by taking the quotient, the division of log m over log b. So you take the log of your number m over the log of whatever your base is, and that's going to give you your value of your log. And you can choose any base. So we have our power sheet here. If we see numbers that are in the same base, we can evaluate the logs at those bases and then start to see what their values of their logs are. If we don't see numbers that are in the same base, then we can use our calculator and use the base of 10 to solve that out. And we'll grab our calculator here in a second and take a look at that. But if we head down to problem 3, we got log 216, 36. So 216 and 36, I'm going to check, do I see 216 and 36 in any row? And as I'm looking, 216 and 36 are both part of a base of 6. So I can use my change of base formula. I'm going to take log base 6 of 36 over log base 6 of 216. Just leave that 2 in there. 216. So I can use a base of 6 using this change of base theorem. Now I can use my power sheet. So log base 6 of 36, I can look, that's going to be 2. So my power for 6 to equal 36 has to be a 2, so that would be 2. And then my value of my log for 216 is going to be 3, because it takes 6 to the third power to get to 216. So the log base 216 to equal 36 is going to have to be 2/3. So that's going to be our result. So if we do see our two numbers, our base and our value of our number there, are in the same base on our power sheet, then we can use that base when we do our change of base theorem. Heading down to part B, I would look for 9 and 111. So here's 9, but there's no 111. And 111 is not going to be any power. So here I could just use a base of 10 to solve this one. So I'm going to do log of 111 over the log of 9. So I always take that big number over the small number. So there's going to be what I would evaluate. So I'm going to go grab the calculator, and then we will use our calculator to solve this one. So back to our calculator here, we've got our log button is right next to the 7. So this is log base 10. So go log 111, close off the parentheses. You can hit divide. That's what a fraction bar does. Hit log of 9. Make sure you close off your parentheses. And we should get about 2.14. So that means if you take 9 to the 2.14 power, now this is going to be an estimate because I'm kind of rounding it off, it should be 111. So there it is. So 9 to the 2.14 is going to equal about 111. So if I did the full decimal, I'd get closer to that 111. But the change of base theorem, that is what we'll use here coming up in section 7.5 as we start to solve equations that have logs involved in them. So heading to problem 4, we're just going to look at a situation that uses logs. So this would be a formula that can test the wind speed of a tornado depending on how far it travels. So we got S equals 93 times the log D plus 65. So that log D, that would be part of the log, and then that plus 65 would be the extra number added on. So I would not put that in parentheses when I do it. What is the difference in speed between a tornado traveling 16 miles and one that traveled 8 miles? So 16 is going to be our D and 8 is going to be our D. So we're going to head back to our calculator and we'll put in the formula and then check to see what is the difference. So we'll start with 16. So 93, then I'll hit log, and then our log of our distance, we'll put in 16. Close that off and then put plus 65. So the 65 is not going to be grouped together with the 16. And we'll get our answer. So that wind speed would be 176.98, so about 177 miles per hour. Second tornado went 8 miles, so I'll hit 93 log put an 8 in and then plus 65. That tornado had a wind speed of 148.98. So we'll now try to find the difference. So you can scroll up, hit your first number. We'll subtract that from our second wind speed, get our answer. So the difference between them, we could say that would be about then 28 miles per hour. So we'll round that up, 995. That's going to be pretty close to 28. So 28 miles per hour would be the difference between the two tornadoes. So we're ready for practicing 7.4. We will be practicing those exponent property rules now with logarithms, so that they're derives from those exponent rules, but we'll practice the logarithm rules. So you're now ready to look at your Delta Math Practice 7.4. You can go ahead and good luck.